Hello, everyone. My name is Zach with HP Additive Manufacturing Solutions, and welcome to session 5 of HP's Beyond the Layers, a polymers 3D printing series. Here, you'll build a solid understanding of HP's multi-jet fusion 3D printing platform and how our polymer solution fits into real-world production. Each quick 30-minute session focuses on a core topic to help you get up to speed and ready to work with HP's 3D printing technology. So far, session 1 showcased advanced applications in fields such as orthotics, automotive parts, and drone-based wildlife conservation. Session 2 covered the components of jet fusion 3D printers. Session 3 highlighted their scalability for production use. And Session 4 kicked off our materials spotlight section, diving into our most used material, PA12. Now, we're continuing that section with HP application engineer Jared Wyckoff speaking on PA12 variants for real-world production. As a reminder, we have the Q&A option at the bottom, so submit your questions and we'll try to answer them at the end or get back to you via email. Now, I'm going to hand it over to Jared to get us started. Go ahead, Jared.
Awesome. Thanks, Zach, for the introduction. And I'm going to go ahead and kick it off. So first, little intro about me. My name is Jared Wyckoff. As Zach mentioned, I'm currently an application engineer, but I started about 10 years ago at HP after I graduated with my PhD in chemical engineering from the University of Delaware. Then I transitioned into HP Labs, where I was working on some of our advanced applications for 2D and 3D printing, where I ended up managing a team working on future application projects for 3D printing. Some really exciting stuff. Now, finally, I'm working with the more customer facing with the application engineer role. Really enjoying talking to all of you out there, seeing what you're doing, and seeing how we could apply this technology to what suits you best. So a little bit about today. As Zach mentioned in our last session, we focused on PA12, but there's a lot of flavors of PA12 materials that are offered on MJF. So really hoping that the takeaway from this meeting is which PA12 material is right for your application. So first, I'm going to start with a little bit of the added value of additive versus MJF specific. Why should you choose this technology? Then we're going to dive deep into some use cases, focusing on our 3 variant materials, PA12S or PA12 Smooth, PA12 White, and PA12 Glass Beads. Finally, I'm going to give you a little overarching summary of the PA12 variants properties, and so you can kind of see and try to apply towards your application why you might want to choose one of these alternative PA12 materials versus our incumbent PA12. So jumping right into it, there's a lot of manufacturers out there, a lot of people doing design or engineering work, and you're looking at comparing new additive manufacturing techniques with conventional manufacturing or other 3D print. And so I like to give this slide as a little bit of an overview of why you might want to choose those applications. So first, looking at conventional injection molds, CNC, one of the reasons why you might want to go into additive is customization. New and complex design, production flexibility, cost, lead time savings. All of these are captured in various 3D printing technologies. But then you made that decision. Why do you want to choose MJF? So really compared with other 3D print technologies, we like to focus on the scalability of additive manufacturing, taking it not only from these new and complex designs, but new and complex designs for full production. So you could satisfy not only your beta customers, but all of your customers. Then looking at isotropic part strength, sustainability, and design freedom. All these metrics really giving us the ability to create scalable applications that deliver the same part every single time. So if we take a look at our overarching polymer portfolio, we have our MJF 5000 series, and there's a bunch of different variants depending on where you are. If you're looking just to adopt, grow, or full scale into heavy production. And there's a wide variety of solutions that we'll have webinars that have covered that in the future or in some of our past ones. Feel free to take a deeper dive there or reach out to us if you're looking for more information. But today, we're going to focus on the materials. And in the materials, the first set of them is the PA12. And then today, I'm going to be covering the variant materials, like I mentioned, smooth, white, and glass bead. Just a big overview of them. PA12, really great for a lot of different applications. It delivers low cost, recyclability, mechanical properties, and this has been widely used on a lot of different applications from industrial to healthcare to automotive. But sometimes these application spaces need just a little bit more. And so this is where we offer options like PA12 Smooth. PA12 Smooth has a smoother surface finish, a lower cost to produce due to its higher refresh ratio capabilities, and it might eliminate the need for post processes. This can allow your quicker time to part, lower total part cost, and directly delivering to your application right out of the printer. PA12 White offers a brighter, more vibrant color. So this allows you to either have the white color for your application space or really to give you the ability to dye and have a wider color gamut. And finally, looking at PA12 glass beads, this is really useful in a lot of industrial applications where stiffness and rigidity are essential. Also, invariance to changes, whether it be a thermal environment or a humidity environment. So jumping into it, I'm going to start highlighting some use cases because I think that's really where the bread and butter of highlighting how these different variant materials are useful in our different industries. So as a little bit of an overview, PA12 Smooth has different application spaces, like I mentioned, compared to our conventional PA12. This is really recommended for things like the consumer goods space, where you have a very low cost to entry and you want to try to drive that part cost because you may have other assembly techniques that go into it. Dental and also industrial, where you're making jigs and fixtures that are maybe consumable or changing all the time, and you don't want to put a lot of part cost in there. And so application space, I'm going to highlight in various slides, I'm going to look at something like dental molds, volume production of certain lightweight parts, lighting, aesthetic covers, etc. Some of the times where you may not want to consider this material is if you do have higher mechanical property needs. So in, for example, the O&P market, if you have insoles or things that are going to be facing repeated mechanical stresses, this is where the conventional PA. And again, I'll cover more of those in our later slides where we focus on the differences. But really right now, I want to hop in and highlight some of the application spaces that have seen success with this material. So one of the first ones I want to show is a bike bib holder. So this is something used in sports equipment or the consumer goods space where you have all these accessories that you want to add to whatever application you have. In this case, it's looking at road bikes. And so for road bikes, you know, if you compete, you'll have a biker bib that'll have your number or have your ID or registration for whatever race that you're taking part in, or maybe you just want to highlight some of your flair as you're driving down the road. So this allows for a consumer, in this case Decathlon, to manufacture these accessories that fit your make and model of the bike. So it gives you that customization towards what you're looking for. You also have then the ability to change logos and things like this, which is, you know, ubiquitous across our 3D technology, but the cost really prevents these from going into mass appeal with other materials like the conventional PA12, where PA12S has this high cost reduction, allowing to get up to 25% cheaper. Also, the improved quality of the surface finish out of the printer really enhances the ability to print, post-process by just sandblasting, and then dye deliver. And really with this, you create this on-demand productive where you don't have to have SKUs of these sitting in a warehouse. You can manufacture just in time. If a customer orders, it could be purchased, it could be customized, and it could be delivered. And then allows for market testing. You know, you could test the waters. These could be giveaways that highlight a particular event. And really that leads into the customization potential. Really see that as a big space for additive. And PA12 Smooth with its lower cost really helps to enable. Another application space is a bike connector cover. As EV bikes are starting to become bigger application space, accessories to suit them are also becoming large. And there are some parts that unfortunately get lost. And one of the things that gets lost a lot is the bike cover or the electrical cover for your charging port. And so with this, Decathlon also decided to go in and design some conventional designs that will fit standard EV bikes that allow the customer to customize, to have this protective function in case they accidentally lose it, but also deliver this at a lower cost where conventional manufacturing technologies may be able to achieve the low cost, but you don't get that customization and you don't get that brand labeling or direct customer labeling to allow you to feel personalized to these parts. Which again is another really big application space for additive manufacturing, is that one-to-one, being able to deliver something right for your customer at the cost, at the function. And then another one is looking at dental molds. So dental molds, these are kind of like for the retainers or aligners that are clear. They use 3D printing to create thermal formed templates or thermal formable templates for your teeth. And one of the big driving costs of these is accuracy, smoothness, and cost. And PA12 Smooth delivers on all three of those fronts. So looking at the enhanced aesthetics, this saves a lot of time from the time to print to the time that they can go into that thermal form process by eliminating a lot of the conventional sandblasting that went into traditional PA12 manufacturing of these type of devices. Also, being that it's a smoother surface, the molds that are created from these that you will eventually be wearing have improved transparency because they are overall smoother. And then finally, the lower cost due to the increased recycle ratio of PA12 Smooth allows for that treatment procedure to reduce in cost as well, being able to get to more customers and satisfy their needs. And then finally, one of the PA12 Smooth applications that I want to highlight is in the consumer goods in the housing industry, looking at both lamp covers where you could have custom aesthetics for your home, for allowing interior designers that design freedom and variability, that they don't have to buy things off the shelf. They can custom create, but do that at acceptable costs. And again, looking at housing covers, things to cover lamps and light fixtures and switches that may not be seen before. And that's one, open up the aesthetic design changes, but also two, really get some creative application spaces going on as well. And, drive innovation on all fronts from the design to the use cases. So finally, I just wanted to highlight a little bit of post-processing for PA12 Smooth. Really lines up well with our PA12 conventional, but really enhances the surface finish at less application. So conventional sandblasting really is the heavily workhorse in cleaning the powder off of our powder bed fusion based MJF technology. With PA12 Smooth, you get quicker time to a smoother finish. Again, our dyeing and vapor polishing processes still work on this material. So if you do need a next level enhancement, you could achieve that with vapor polishing. And then similar dyeing options to PA12 are also available. And so this starts with a grayer based. So you typically are stretching into the darker color gambits of additive dyeing solutions. So overall, just to kind of highlight, PA12 Smooth really focuses on cosmetic, low part cost, and minimizing weight with its exercising the higher refresh ratio. So now I'm going to hop into our next variant of PA12 White. PA12 White really offers this similar durable and high-performing PA12 properties with an enhanced white color. So we achieved this through some additives to the powder to brighten up that powder color, as well as a different agent system that doesn't provide that black dyeing effect as it's going through our MJF process. Again, it's effective and sustainable, offers that balance between part performance and material reusability, and it's great for applications like medical, orthotics and prosthetics, and consumer products where either white's a requirement or you want to diversify that color spectrum of dyeing. So I'm going to highlight a couple of examples here. This one is a cranial orthotic, which really is focused on correcting deformities in infant head shapes. The Invent Medical has launched the Taliban in partnership with the MJF, and really has highlighted their ability to create design aesthetics using additive manufacturing, but also deliver colors that are both child and parent friendly. When you're putting a helmet on your newborn's head, you want it to be a bright, vibrant color. You want it to light up the day. And that's really where the PA12 White allows that improved aesthetic customization, but also that post-processing freedom to meet those color palettes that are really desired by both the customer and the clinicians alike. Another example in the O&P space is looking at AFOs, and in particular, the SMO by Molecular, saying that wrong, orthesis by CureLab, where again, they had that design freedom that was enabled by MJF, but they were able to add that extra step of the PA12 white, giving that extra color palette, and also playing off the benefit of improved weathering. So the additive that we add to the powder also enhances its UV stability. So if something is going to be on your foot and exposed, you don't want it to degrade in the sunshine or change that color palette. And our PA12 white additive actually helps enhance that. And again, this allows for efficient in-house manufacturing, optimizing the patient care, going from that scan to a part that is a one-to-one correlation, eliminating post processes, which is big reason why the O&P industry has adopted 3D print so. And then finally, looking at Custom-Made for the O&P customers, really focusing on printing custom casts to prevent or heal twist fractures. And again, taking that similar design aesthetic, that unique open air design to prevent that cast smell, and then adding that color facet on top of it, really giving the customer what they want and allowing either customization of coloring solutions on top of their cast as a white template, or being able to go into dyeing solutions and give them the colors that they want to accessorize as they're healing from their twist fractures. Next, looking at medical device covers. As I mentioned, in some of the medical devices, white is essential. This is something that they want in all of their application spaces, is that white color, so you can see if it needs to be cleaned off more clearly than if it was a darker hue for an accessory or a device or anything that's being installed in hospital or doctor's offices. And so by delivering this PA12 white solution, utilizing our technology, you get that design freedom. You're able to create these complex freeform designs, but also give that essential white coloring that allows them to meet their standards for installing in medical type scenarios. And then I'm going to take another look at some custom iframes. This is, again, another consumer good application looking at eyewear. And so obviously getting into the fashion and design space, there's a lot of creativity that's hindered by either conventional manufacturing's cost requirements or by standardization. And so the Lick eyewear really enjoyed the design freedom that MJF offered, but with conventional PA12, they didn't have the color freedom or the palettes that they were able to test out. And really having the PA12 white allowed them to have the mechanical properties necessary to meet their needs, plus give them the opportunity to further express their design creativity. And then again, looking at automotive afterparts, aftermarket parts are a big space, not only to provide good high quality parts for legacy cars that maybe have aged out, where OEM is either preventable or preventative due to cost or not available. Or you want to add your own personal flair to your car. And so aftermarket parts have utilized the PA12 white to allow for a wide variety of textures and styles and post-processed colors to give the customer that palette that they want as they're choosing to buy accessories for their vehicle. And so I'm highlighting some handles, but there's a wide variety of application spaces that allow you to translate the plastic elements in your car into custom creations for you. And really, one of the things that you heard a lot in the PA12 white was that color palette. So I did want to highlight, especially from one of our partners, Dimension, the enhanced color spectrum that you get. You could see the more vivid blues and pinks and yellows that you're able to achieve with this enhanced standard color that's available on the PA12 white. And typically our PA12 white solution is only available on our 5400 series printer, which is focused on that agent that gives that high white popping color. But we've also recently brought this to our newer 5600 line of printers, where you are still using the conventional fusing agent, but with that white additive into the powder, you can get what we call the light gray solution. And this gives you the kind of best of both worlds, where you don't quite hit the white, but it's at a lower price point. And so you still can exercise some of that wider color gamut. It isn't quite as good as what the white would achieve, but it gets you close. So with that, I'm going to transition over into our last variant, or our PA12 glass beads. So looking at our PA12 glass beads, again, like I mentioned at the introduction, this is really where dimensional stability, stiffness, and invariance in different environments are essential. And so some of the key application spaces that take advantage of this material are in industrial and in automotive. Stuff like tools, jigs and fixtures, casings, housing, robot end effectors, where you want that precision and control and understanding that where that device is going to be in the same place after many, many, many repetitions. And then in automotive, stuff like fluid management systems or ducting, frame support for electrical conductors, and as well as in that prototyping basis where you're creating those runs that are actually operating prototypes. You want something that's going to be able to demonstrate something new, but also work effectively. And this is where PA12 glass beads has been able to offer good solutions. So one of the ones that I want to cover at first is looking at a solution by Wyckoff 360, where they built a vacuum end arm tooling. So this is a device that's at the end of one of those cobots or robotic solutions that is enabling grabbing and vacuum suction to pick up devices. So in this, the overall opportunity use was focused on two materials, the PA12 or PA11 and PA12 glass beads. We'll cover PA11 in another presentation, but PA12 glass bead was great for that strength in different sections of the part, especially because this replaced a traditionally aluminum part. They're used to that rigidity of the metal, and going into the plastic solution helped them to save a lot of material cost, save a lot in the manufacturing cost, but also save in the weight of the operation. This savings in the weight reduced the requirement from the robot that was controlling the device in the first place, thus giving a whole system that they could deliver at a lower cost. And that's another great example of where you can replace an incumbent material or an incumbent design with something that's lightweight, that has generative design structures that really can save on the whole solution versus just that part. Another great example is from ProMetal 3D, where they have a laser cutting apparatus, and they were able to, again, replace a machined metal solution that was a multi-part assembly to a single printed piece of PA12 glass beads. This gave them the precision and the rapid prototyping to iterate, and then also achieve their needs for short run production. So they could, create this design, print on demand when needed, and get this same engineering material level performance that they were seeing with their conventionally metal machined part in this polymer part. So this significantly improved their weight, and were able to achieve about a 75% weight reduction, enabled a smaller, more efficient robots, saves size and space on their installation. And so overall, we're able to allow them to create a better overall solution for their application. And again, another example of this is more in the machine equipment casing. So, some of the casing applications that I mentioned before maybe don't have the right rigidity or stiffness for their application if there is going to be heavy stresses placed on it. And this is where PA12 glass beads can step in and give you that design freedom, give you that customization or that brand awareness in short run production, but also achieve those durable materials that are going to stand up for more harsh environmental conditions, as well as give you that rigidity that they're not going to bend and flex like some of the less stiff PA12 variants. And then finally, I want to transition over into some of the automotive solutions where using additive design has enabled really cool optimization of performance. So looking at this cooling manifold for EV batteries, you're able to use CFD technology to design optimum flow structures that meet your application constraints and deliver on what you need, but also utilize materials with the PA12 glass beads that are going to be similar to your conventional technologies and also achieve lightweighting, especially if they're metal replacements. You can build in probes and sensors by creating unique ports at the location that you want to gather the information, which again is something that's preventative depending on the conventional manufacturing technology that you're going. And then, easy design changes and managing multiple SKUs, the whole thing with the digital inventory. And so even though the per part cost, as you can see from some of the cost estimates in the bottom right, is a little bit more expensive, the ability to not have to go into an entire tooling or not have to create large numbers to achieve this price point in traditional manufacturing allowed for lower cost at the production capabilities of this particular customer. So a lot of times what works for one customer doesn't work for another, and you have to factor your needs into the materials and the processes that you're selecting. And finally, I wanted to end on some of the other EV opportunities just to highlight a few. Anything dealing with temperature fluctuations or in terms of electrical connections, PA12 glass beads ends up helping out a lot just due to its high HDT or its invariance to change as temperature cycles, its ability to manage fluids for cooling systems, and then have rigid connectors that are going to hold and keep that same pressure over the amount of time for these applications of need. So jumping into a little summary of the PA12 glass beads, again, this is ideal for stiff, dimensionally stable, quality parts. This delivers high HGT or heat resistance, low change in dimensions in presence of fluid, high resistance to wear if this is in a repeatable application, and it gives a balance between high performance and reusability. So you still achieve up to a 70% reusability, which obviously is not significant compared to like the PA12 Smooth, but again, that's why we offer these different variants so you can select the material that's right for you. So just to highlight again, enclosures, housing, frames and supports, fixtures and toolings, as well as fluid management systems are great for this material. So finally, in the last few minutes of this presentation, I'm going to be highlighting some of the variant properties. And I put together some nice comparisons. There's also some other materials in there, so you'll get to see where PA11 and polypropylene compare. Those will be covered in future presentations like this. But really what we see is PA12 smooth, PA12 glass beads, and PA12 white in the light blue, dark blue, teal, and orange colors. So looking at strength, PA12 still is going to be the strongest contender here, where PA12 white takes a little hit due to some of the additives in there. PA12 smooth offers that surface smoothness, but at the cost of some mechanical properties in terms of the strength. And then PA12 glass beads, even though it is more rigid, it isn't as flexible. And so the strength figure of merit does take a hit. You see that again highlighted in the elongation of break. But really, as you go into the rigidity or the tensile modulus, the glass bead stands out ahead. And then in impact strength, they all have somewhat nominal performance, with the PA12 and PA12 white having high performance and the PA12 smooth falling behind. Taking into consideration some other more aesthetic or more softer properties, look and feel, the PA12 smooth out of the printer is going to give you some great properties with PA12 and PA12 white, and then followed finally by PA12 glass beads. Dimensional properties, again, all of them performing strong. This is really meeting those fine features. PA12 glass beads, due to that it's a little bit of a composite, does have some more stricter design guidelines. Variable cost per part, PA12 smooth obviously stands out, with PA12 being the mid-range, and then PA12 white and PA12 glass beads being comparable price. And then with reusability ratios, smooth stands out as the front runner, again, correlating to cost, with PA12 having the next best refresh ratio, with glass beads and white having very comparable. And then in carbon footprint, they all achieve well, but the additives introduced into the glass beads and white do stress that a little bit more adding a little bit more carbon footprint to the overall manufacturing process of these powders. And finally, just as a highlight in our last minute, PA12, great for strong, functional, high detailed parts. If you want to go into the PA12 smooth variant, this will give you 70% smoother, low warpage, good UV resistance with the best refresh rate. White stands ahead with the colors and color spectrum that you're able to achieve. UV resistance, but there's a little bit more cost as our conventional PA12. And then PA12 glass beads really delivering that stiff, dimensionally stable, quality parts for a lot of those industrial and robotics applications. And with that, I'd really like to thank you for the time and just let you know that we're here to help you identify the right material for you. And if you need anything, feel free to reach out to me. And then Zaxon also provides some additional information and follow-up emails on this for future presentations. Thank you so much.
Amazing. Thank you, Jared. That was great information, and I appreciate the overview of the differences in the variants and the different applications that we have so far with these. Um, it looks like we're at the 30 minutes, so if you submitted any questions, we'll get back to you via email shortly. You'll also be receiving an email with today's replay, a link to our previous sessions, and the registration link for session 6 topic. Continuing in our materials spotlight section, talking about more possibilities with TPU, TPA, and polypropylene, where we'll discuss our flexible and our chemical resistant materials. I want to thank Jared for presenting today and thank everyone for attending this session of HP's Beyond the Layers. I hope everyone has a great rest of your day, and we look forward to seeing you in the next sessions. This next session. Bye, everyone.
Bye, everybody.